All right. Yeah. So today's topic is HTTP. I think Tim said it. It stands for Hypertext Transfer Protocol. But what does that actually mean? Does anybody have an idea?
I think what Jack who said it pretty much is how the web uses certain protocols to move the information around web page to web page. I mean, the information behind it.
Yeah, it's essentially how websites talk to. Essentially, it's like the ethos of the internet. How websites talk to one another, or how web pages talk to servers, and etc., and back and forth. So just keep going. So it's essentially how information is sent over the web. There are very specific rules on how that information is sent. So HTTP connects the world. It stands for Hypertext Transfer Protocol. The protocol was originally described in 1991 with the origins of hypertext dating back to the early 1930s. It's since obviously evolved substantially. You no longer can just send hypertext. You can actually send HTML, and that's where what's mostly sent. It's HTML, but you can also send a lot of other items. So HTTP protocol was originally designed as a protocol for transmitting specifically hypertext. As now it's pretty much all HTML that we're sending over. So before it was just hypertext. Now it's hypertext markup language. Today's HTML has grown to support much more than just linking from one page to another, but it was the concept of linked pages that uniquely defined the early web. So that's what the hypertext essentially links to other pages on the web. So while also transmitting like HTML, you can also send all different types of assets over there, like CSS, images, video, JavaScript. I mean, if you think of Netflix, what they're sending over, like the streaming of videos, all via the web, HTTP. Any questions about what we can send over?
Oh, what was that about it starting in 1930?
I think like the core concept of it. Like
how?
I don't know. I have no idea. But yeah. All right. So HTTP involves two different parties. There's the client, which is us, like whatever we're doing in the web browser, as well as the server. So as a client, if I go to, Amazon.com, I'm making a request to Amazon.com. So Amazon.com as the client, I'm the client here. I'm making a request to Amazon.com. And the server, being Amazon.com, is sending a response back to the client. So I'm making a request to someone and I'm getting a response back. Just like if I go up to, I'm at a dinner party, if people go to dinner parties, I don't know. Or if you, are meeting somebody new, I go up and I say, I'm the client. Hi, my name is Tom. I would generally, hopefully, get a response back from that person and be like, hey, nice to meet you. My name is so-and-so. So both HTTP requests and responses are in plain text as well. So if you think about it's literally just a plain text that is being sent to the server and also getting a response from the server. So it's nothing fancy. It's all literally just plain text. What questions do you have about the client and the server? So as a client, I'm like right here. I'm the client. I made a request to this specific Google Doc, and I'm getting a response back, which is this information right here, this HTML. All right. Let's see. So you'll hear, here we go. Yeah, let's actually. So there's the request line you'll hear these common verbs, get, post, put, delete. So a get request, so let's just come here. A get request, so over here we have an example of a request and a response. So again, this is all sent in plain text. On the very first line, we have the type of request, which is a get request. Get request means you're going to the server and trying to receive some information. Post request is you're sending information from the client to the server, and you're generally saving something on the server in the database, generally speaking. Put request is you're updating as a client. I'm sending information over and I'm updating an already existing information in the database. And delete, again, I'm sending information over and I'm requesting to delete information from the server. So you'll hear these common get, put, post, delete. And there's other ones like patch, but those are very rarely used. The most commonly used ones are get, post, put, delete.
What's the difference between post and put?
So post is you're sending new information to the database, such as I sign up for a new account on Amazon. That is new information that I'm sending to Amazon. So that is a post request. Now, say I already have an account on Amazon and I decide to update, my address there, that would be a put request. So I'm updating already existing information in there. Or I updated my last name or something like that.
So get is the only one that's from the server to the client. The rest are client to server?
These are all client to servers. So I'm doing a get request to the server and the server is going to give me some information back. So, but I'm not actually sending specific information to the server. And we'll talk about the difference between get, put, post, delete, and like what is actually different in that request. So here's an example of a request and a response from the server. So I'm doing a get request to some URI, and the protocol I'm using is HTTP, Hypertext Transfer Protocol, and version 1.1. Let's go through. All right. So this is the request line. Let's just keep going. Whoop. So yeah, this is the request line, and it's separated into three parts. As I said, it's the type of request, the URI, and the actual protocol version. So it's the type of request, it's a get request. The method is a get method. The URI, this is the actual, pretty much everything that comes after the slash of the host. So I'm retrieving the bio.html page. And then the protocol version, I'm using HTTP protocol version 1.1. There's also, I think it's protocol version 2 and protocol version 3, but those are I've never seen them used before. So pretty much everybody uses protocol version 1.1. Questions about the method, what I'm retrieving, the request line, or the URI, which stands for Uniform Resource Identifier, and we'll get into that. So this isn't the URL. We're not going to the URL. And this is the protocol version, HTTP 1.1. All right, so the request line, as I mentioned, this part, the URI, Uniform Resource Identifier, is literally pretty much everything that comes after the slash of the host name. So let's talk about the request again. So we've got the request line, the host, and some headers here, but we'll get into that shortly. So the URN is the host and it plus the URI. So example.com or google.com / whatever the URI is. And what most people are familiar with is the URL, which consists of the protocol, the HTTP : / followed by the host, followed by the URI. Does anybody know what URL stands for?
Uniform Resource Locator.
Mm-hmm. How about URN? Just uniform resource name. Yeah. So URI, uniform resource identifier. So it's trying to identify what specific asset you're trying to receive. It usually comes again after the / from the host. So in addition to the request line, which consists of, again, the method, the URI, and the protocol version, they also have on the subsequent lines something called headers. So headers consist of the host as well as the user agent. So the user agent is like, where are you sending this request from? And this is usually the Chrome, like the browser version you have, or that you're sending the request from, such as like Google Chrome 52.34, or it might be like Safari, something like, or maybe it might be something mobile, might say Android. And so when you send the headers over, the server can look at the user agent and send back specific resources depending on what user agent you're using, such as maybe you're sending something from mobile that has like Android or Safari or something. You can send specific assets over depending on what browser you're using. Questions on the headers portion? All right. So notice how in the when we're sending GET request, all we need to do is send the request line and headers over. But if we want to send specific information to the servers to save it, such as a new account, or I'm ordering something that's going to be saved to the database, I want to send over a put request or a post request, specifically, let's just say a post request. So the post request consists of the request line, again, with the method. This is going to be a post request. I'm going to the URI of search, and the protocol version is HTTP / 1.1. I'm sending over the headers, which consist of the host, the user agent again, and the content type that I'm sending over. It's generally application X www form encoded. And then there's a space followed by the body. And this body could be anything I'm sending over. It could be my name. Here, for an example, I'm sending over query equals new plus Jordan's and color and red. Where am I looking? Where did it go? So that literally would look like post / search HTTP : 1.1, one line, and then host example.com with user.
Anytime put double H's.
Oh, yep. User agent, so-and-so content type with some content type, and then 2 spaces, and then whatever I want to send in my body. And again, this is all plain text that's being sent over the wires. Now it converts it, but yeah. So request bodies are most commonly used for post, put, patch, and delete requests, and include all types of content, such as images, uploads, form content, etc. So you can send pretty much over anything in the body.
What's the nature of the application and content type?
I don't know specifically what this specific means. I think it's just what I'm sending over, but you'll see content type of text, JSON, like various different content types. Content type, HTML. If you look at Mozilla content type, there's all kinds of different stuff you can send over. All right. So HTTP request with query parameters. So has anybody ever like gone to, where'd it go? Like, I don't know, so here's just a website that has like leather goods. If I notice how when I click that, or I'll actually just go to Amazon. Gaming.
I've got a question if you got a sec, Tom.
Yeah.
In the address bar, the web address bar, like that specifies whether it's secure or not, like HTTP versus HTTPS, right? Like that little lock icon.
Yep. Yeah. And we'll get to that in a second. Essentially, where'd it go? So query parameters. So if I do a GET request, anything after a question mark is considered query params. So when I send that over to the server can extract information from here and send stuff back. So additional request data can be included as part of the UI instead of just being included in the request.body. So if you've noticed, where'd it go? When I go here, I don't know if there's a question mark. So right here, this is the request parameters for a bunch of different information, probably the product, probably some other information as well is stored within here. I just want to see if there should be query params in here as well. Bad. Yeah, so here, there's some query parameters in here as well. So query params are separated from the URI with a question mark, and individual query params are separated by an and symbol. So if you wanted to add multiple queries parameters, it's separated by an and sign. So query equals, it doesn't always have to say query. That's just dependent on whatever application you're using, whatever website you're on. The ampersand, or I'm sorry, the %20 is, I think, Unicode for a space. And the and sign is like another query. So query Air Jordans and color red and size 12, something like that.
I've got another question, Tom.
Yep.
When you were just talking about that, so does that specify like a Boolean search term? Like, have you ever heard of that?
A Boolean search term, like true or false? Or no, I've never heard of that.
No, I just meant like when I was, sometimes you can use like a capital letter, like and. I mean, totally unrelated. I was just kind of curious.
Oh, yeah, no, I don't, yeah, I'm not quite sure. So let's talk about request headers again. Request headers provide additional context about the request. You can send there's a bunch of stuff you can send in the request headers, such as the host, example.com, tells the web server which domain the client is requesting content from. Often a single web server will serve content from multiple domains, sometimes called virtual hosts. The server uses this header to determine which content to serve. You can talk about accept language, so you can know what language to send back, or to even accept. So if someone says accept language English, the client knows to serve up English. If it was Spanish, Chinese, etc., you can send up different language back. The user agent, which type of client is sending this request. Sometimes, depending on what user agent, we might send different assets back. Accept, what format response is the client interested in receiving? So for example, when I send this request, I'm only willing to accept text and HTML, text or plain, or JSON, or some other information, maybe just images, etc. So I sent a request. Now I get a response back from the server somewhere. So the server has a status line of HTTP, the protocol version, the status code, and the status, the status line or the status phrase. So HTTP protocol version 1.1, 200 is a status code, which means everything was, the response was, or I'm sorry, the request was successfully received. Also the content, or I'm sorry, the headers, which consists of the content length, the date, content type, and there might be other information. Followed by a blank line, and then the body. And the body is, generally speaking, most of the time HTML, but again, it could be images, it could be JSON, it could be a bunch of other information. So once it's sent that back via HTML, your web browser does all the parsing and displays it on the screen. So response line, response status code consists of the HTTP version, the reason phrase, so that's what that's called, as well as the status code. 200 is generally a successful response. So
The famous 401.
I'm sorry?
This is where we see the famous 401.
Mm-hmm. So there's a plethora of different status codes out there. So 200 is okay, means it's success. 302, which means there's a redirect. So if I ask, if I go to, some store and I need some help, and I go up to the cashier and be like, hey, I need some help. And they'll be like, you know what? I'm going to redirect you to my manager over here. So 302 is a redirect, sends me to some other area. 400, bad request. 401 means, hey, I'm not authorized to visit whatever I'm trying to visit. So you'll see that around a lot. 404 is not found, means, hey, I sent this request and the server is looking for it and say, hey, there's nothing, wherever you're looking for is not here. I'm going to send a 404 back. And 500 is internal server error, means, I sent a request to the server and something happened on the back end or on the server side. Be like, oh crap, I messed up, and I'm going to send an error back. So
there's a really cute website that illustrates all of the status codes with cats.
Oh, yep. So all the status codes, whatever that starts with, is generally what type of request it is, or what type of response you'll get back. 200s, anything that starts with a 2 is usually okay. Anything that starts with a 3 is generally a redirect. Anything that starts with a 4 means is not good. Like, you're not authorized. Generally, you're not going to get back what you want. And anything that starts with a 500 is an internal server error. So you can actually see internal status codes. 418, there's on my teapot, you can get that back. This was done as like a April Fool's joke, but it's actually out there. So if you ever get a 418 back. But let's talk about post requests real quick. So you can so let's just kind of inspect what that actually looks like. Well, let's just keep going first. I'll get to it. Response headers. Whoop. So when I visit a web page, like I just did here, no, I don't want it later. If I go to network, the request and response. So anytime I make a request, I will always get one response back. So if I make one request, I'm not going to get multiple responses back. It's always one-to-one. But that doesn't mean a user can trigger. So if I click shop compact, that doesn't mean I'm always going to get one response and one request. A user can interact with it here. Oh, geez, what just happened? And a single, if I click a button, it can trigger multiple requests and responses. But just know that if one request will always receive one response back. So if you open up the dev tools and you go to network, oh my God, this is so slow. What's happening? Should I refresh this? Come on. Actually, I'm just going to go to something less spacejam.com/1996. That should be a little less. So notice how when I refreshed it, when I visited this web page, it made all these requests. So I visited this web page. I go to .com. Here are my headers. I went to a GET request, the request URL, and I received a response back, which is HTML. So you can actually see the response that I received back from this GET request. So you can, it's kind of like inspecting the web page, but you can actually see the GET request I received. Look, it says don't touch ads here. But it also sent back, Google Analytics. So it's connected there. It sent back a GIF, some JavaScript, more information. But you can see that they're all you can inspect and see the type of requests being made in your browser by going to the network tab. So I got the CSS assets back. You can see all the CSS that was sent back as well. All right. So the response headers, you receive the content. What format is the response body? It's usually like HTML text. The content length, how many bytes long is the response body? This tells the user or tells the client how many bytes to read from the network socket. What currency? For example, if I send so if I log in and to like Facebook and I get a response back, it might set a cookie of like a specific token or my username and set it to it might set it to my local storage or something like that, or it can set a cookie. It could also send the date, specifically when the response was sent. So many HTTP conversations. Imagine a user browsing a few pages on a typical website. Dozens or hundreds of HTTP conversations will take place. I kind of showed you that with the Space Jam. So if I click Jump Station, it sent back a bunch of assets. So if I refresh that, You can see all the different assets. Now this is not that much, but if I go to like target.com, clear it, you can see all these assets, all these requests and responses being sent back to the web browser. And you can see the status code of all of them. All right, so loading the home page, one HTTP request, one response, one request and response per CSS file, loading JavaScript, loading images, loading video, everything. Questions you have about the request response?
A lot of that stuff will be cached locally then for a while.
Yeah, it depends on the browser and what you have stored locally, or what settings you have locally. But yeah. All right. So there is no, so every time you make a request, the server has no idea of any previous requests you've made in the past. So it's stateless. It has no idea what you did in the past. So it's like the first time I visit, Amazon, it has no idea. So yeah, essentially it's just like meeting for the first time. So the first time I visit Amazon, it will send me the same response back as if I visited the 100th time I visited it. And it literally has no recollection of what I did in the past. So it's a very important characteristic of HTTP is that every conversation shares no state with any previous conversation. So every HTTP conversation begins with a new connection from the client to the server. It's as if two parties are meeting for the first time. Even requests made just moments before have no bearing on the current request. So most servers clear all state variables with each request. This means all state when processing a request comes from the request itself. So when I send a request back to the server doesn't know, it's not storing anything about that request once the connection is, once the response is successfully sent back. That is if there isn't something set in cookies and we're not sending that information back. So HTTP cookies help retain state like who was logged in or what was their last search across multiple requests. So just like when you log into Facebook for the first time, you exit the browser, it stores something in your local storage or in your session or in your cookies. So the next time you visit Facebook, it will send some token back to Facebook in the body of the request and look in the back end, something stored in this, like in the database that says, hey, I'm logged in, and it logs you in automatically and sends that request back as you logged in. So you'll learn more about how HTTP cookies work, but for now, here's a summary. The server sets cookies by sending them to the client as part of the HTTP response. The client stores the cookie locally in the browser. The server does not store any cookies. And anytime a user sends a response or a request back to the server, they'll send the cookies back in the request. So in short, summary, HTTP protocol is a proven protocol. It's extensible and has found uses far beyond what was imagined originally, 30 years ago. It's relatively simple, human readable, and easy to parse with code. Again, it's sent in plain text. HTTP first changed the world by connecting users and servers to form the web. But today it's the foundation of so much more than the web. You'll soon realize that HTTP is everywhere. So with that, what questions do you have about HTTP? All right.
So other than like stuff happening in the background, and like we can inspect for this stuff, but how much functionally would we like? In what in what spot would we, or like what kind of job would we functionally use this?
HTTP or like sending requests and responses.
Like anything outside of the scope of what an average user would use. Like obviously there's using web browsers, but
Well, you'll be using it because you'll have to build the request. When you're like storing information, when you're logging in a user, you have to send that user information back to the server, and you have to create the request. You'll actually essentially have to create this request. But luckily, JavaScript has some built-in methods that kind of create the architecture for this request. So it makes it relatively easy.
got it. Thank you.
Yeah, but you'll have to know like the content type, authorization, the different headers to send back.
Would that be more of a function of front end, back end, both?
Both. Yep. All right. So one last thing with regards to HTTP, there's also HTTPS, which means whenever you're making a request to whatever server you want, it says it's secure. So notice how it's got a little lock on it. That means when you're sending your request over the wire, it's encrypting everything. And also when it's sending it back, the response is also encrypted. So that means when you go to sign up for something, you type in your username and password. If you ever type in your username and password with it to a website that has just HTTP, that means your username and password are exposed when it's going all the way to the server. It's not encrypted. So when in doubt, make it secure, but yeah. Where'd it go? So if I wanted to go to Google, I do curl Google, you can see everything that's sent back in the body of the response.
So what would you be able to do with that kind of info though?
With this information,
Yes, like what stuff, or like what's the purpose of this, I guess is kind of what I'm getting at.
it's just doing to inspect specific information. Like you can, if you're doing like writing an application and you want to go to a specific URL on your application to see if you get a successful response back, it's just an easy way to do it. So that's like the main thing. But honestly, I rarely ever use curl, but just know that it exists. You can also add, get more information on the request or on the response by doing curl space -v, and you can get all the header information as well. And whatever this is, I don't even know what this is. Say hello certificate, but you can also see the, where is it? So yeah, it looks like HTTP2. It's using the not 1.1 protocol version. It looks like it's using the 2 protocol version, which is pretty interesting.
I mean, if you just wanted a response, you could just use ping.
Yeah. But there's, yeah. So there's curl, but I also kind of want to show you what other, there's this application called Postman. So if you come over here, Postman is an application that we use a lot as developers. Don't save. So it allows you to make different post requests, put requests, get pretty much any type of request that you want, and get a specific response back, obviously. So for example, as I just went to Google, or let's actually go to GitHub. So GitHub, I'm going to make a GET request. See, these are all the different types of requests you can make. I'm going to do a GET request to today's material. I'm not adding any parameters to, so just like when I was talking about querying in HTTP, if I want to do like name, notice how name, value, Tom, notice how in the URL, it adds those values to it. So it's an easy way to do send GET requests. Authorization. Now you can also see the headers that are being sent in the request. These are all default headers coming from Postman, but I usually don't mess with those. So if I want to do a GET request, the response will show up down here. So if I click send, here's the response I get back from GitHub. Kind of interesting. But what's more interesting, oh, go ahead.
I blinked. Was Postman an extension in VS Code?
No, it's a totally separate application. So if you click on Postman, I would download Postman to use it. But okay, all right, as you said, like, well, what are we going to do with this information right here? Like, it might be interesting to inspect, but maybe you wrote an application that you want to send, like, log into and get all. So once we actually start building out web applications and with a back end and we sending responses back with actual data in it, this is where this information is good. So there's this website called JSON Placeholder. It's literally just to test a HTTP request to get data back from. So if I go to guide, and if I go to HTTPS, JSON.placeholder, that typecode.com, I can see that. And I'm doing a GET request and I send that back. Notice what I get back. I'm not getting back HTML. I'm getting back JSON, JavaScript object notation of all these posts. I think users is also one of them. So I can get users back. So maybe your application sends back all the users back. So this is what's being sent back in the body of the request. It's JavaScript object notation. And what that looks like raw is like this. This is what is being sent back to the browser or to the front end.
So is that information real information or fake? I'm going to assume that it's fake.
Yeah, this is all just fake information.
Okay.
But it's called JSON placeholder. It allows you to test out whatever requests you're making to see if there's actually it's like a valid request. So I can go to users. Maybe I want to grab the fourth user. So I've got grab the fourth user. Look at send a JavaScript object notation of ID, name, username. So if I got this back from the client, or I'm sorry, the server, now as a developer, if I'm a front end developer and I'm working in React or JavaScript or even Django, I get this back and now I can do stuff with this information. I can display it on the screen to make it more dynamic. And we're going to get to that in the coming weeks. So that's with a GET request. But notice in the GET request, I'm just using the URL to get information from the server. But there's other requests we can use, which is a post request. Maybe I wanted to send information to the server and have it do something. Let's see. So, for example, maybe I want to send, let's actually use posts. So maybe I want to get all the posts So here are all the posts. I've got user ID, title, body, but maybe I want to post to the actual server and save information into the database. Does anybody remember what other information in the request I need to, like, where do I add that information?
Are you talking about like the host and the URN?
So I've got the host, the URN, but when I'm sending information, where do I put the information I want to send to the server? Where in the request do I send that? Do I put that? Does everybody?
Is it? It's not the body, is it? I know it's.
Yep. No, you're exactly right. It is the body. So for example, I'm making a post request, and in here I'm going to the body tag, and this is what I'm going to send to the server. So I'm going to do raw. So you can put it in different formats. I'm going to do raw. I can do text. I want it to be JSON. Whoop. So I'm going to send this back in JSON. So I have to kind of format it as JSON. And so I'm making a post request. I'm just title, Tom's title, body. This is the body, and user ID is whatever. So if I send that, I get a successful response back, and what they send back to me is what I sent to them. And you can kind of see title, body, username, but now the ID, it sent back the ID of that post.
So if it failed, would you get back like one of those error codes?
Yep. Let's see if something happens, if I send. All right. User ID didn't work. So I wonder if I sent something else. It might not. So this specific request is allowing me to put whatever I want there. But if I didn't format it to JSON, so if I send something like that, I get a syntax error, expect token K in JSON at position, blah, blah, blah. Let's see if I send this. So yeah, it just allows me to send anything to it. But if I wanted to do like a post to like Google, let's see what happens. We're gonna do a post request to Google and Tom's post request. Let's see if Google will allow this to come back. And a lot of the times, even if it's a failed request, they'll send back a 200 request, but it might have some messaging in there. So look I sent a post request to google.com. In the body, I put title, Tom's post request, and I get a 405 method not allowed. So I'm not allowed to make a post request to google.com. And I usually just get some HTML back. So notice right here, it says that's an error. The request method post is inappropriate for the URL. That's all we know.
I think if you click raw, you can view it as HTML at the bottom.
Oh, yep. So yeah, and you can also
preview. That was it.
Yeah. Yep.
So is that Google's way of saying nice try? Back
Yep.
off?
Yes.
Pretty much. All right. Let's So in addition to Postman, we're going to kind of switch topics right here and talk about where can you host a portfolio website or a project instead of going out and buying a domain from, Amazon or, Google or GoDaddy. Well, has anybody heard of GitHub Pages? If not, what's that?
Nope.
Well, GitHub has a way to essentially host your website, like host a personal site. So if I go to github.github.io, I've got my little personal website. So you can kind of create this as like a personal GitHub site. So how you do that is if you type in, why is this going so slow? So for example, if I wanted to create a new Oscar Platoon GitHub, personal GitHub, I'll kind of walk you through the steps. So the first thing you need to do is create a new repository called, it's actually, there's Jesus Christ. GitHub Pages. So if I go to GitHub Pages, you can host a personal site as well as projects. So if I'm going to come through here, what is GitHub Pages? You can watch that, but you can use a project site or like a your actual like personal site. So there's two different ways to do it. So if you're just creating a personal site, like I kind of showed you with mine, I'll show you how to do that. So head over to GitHub, create a new public repository and name it username.github.io. So if I go to Oscar Platoon, I'm going to name it oscarplatoon.github.io. If I create that repository, and I'm going to open a new, where is it? Window. Whoop. And if I do CD desktop, CP challenges, CD Oscar Platoon, make directory, Oscar GitHub page, CD and Oscar GitHub page, list everything out. I'm going to touch index.html file and styles.css. I'm going to code index.html and styles CSS. Yes, open. So I've got my personal web page up and just do HTML. Div Oscar Platoon. And over here, just put body, text align, center, margin top 10%, and div font size 66 pixels. And I'm going to link that thing. So I just created a quick web page. And now, so here I created a brand new GitHub repository called oscarplatoon.github.io. If it was yours, it'd be your GitHub name. So my name is tompreet.github.io. If Tim Gaston's was Tim tim-gaston or tim-gaston.github.io. That's what it would be. So I'm going to also touch a readme.markdown code readme. I'm sure Oscar Platoon GitHub page, whatever. So I'm going to git init, git add. I'm going to add everything. Git status. So I'm adding the readme index.html and styles file. I'm going to commit, git commit, first commit. I'm going to change the master branch to be called main. And then I'm going to add this to link up to with this remote. And then I'm going to actually push it to this repository. So if I refresh that, I've got Oscar Platoon GitHub pages. And now if I go to, everyone can go to this now, oscarplatoon.github.io. And it might take a second. Let's see, but it should update this. So kind of gives you examples on how to update that. Now, that's for a personal website. So like your personal user or an organization like GitHub or like Oscar Platoon. But if you're making a project site, it's a little bit different. You essentially will have to create a new GitHub repo, call it whatever you want, and then in order to, why isn't this working? In order to visit it, you would visit your like GitHub repo name, and you'll be able to visit whatever project you're doing, whatever project you want. GitHub.io. I'm just making sure everything's working.
Does it matter that you made it private?
I don't think so. Yeah, this
I made one publicly and it's working for what it's worth.
So yours is working?
Yeah.
Nice. All right. Yeah. But yeah, that should show up. It might take a little while because GitHub has to like update it. So that's a really easy way to test out things with your projects. But just make sure it needs an index.html file. Once we get into React, if you want to actually host like a React application up there, that's a little more complex and it requires a little bit more customization to get it working up on GitHub, used through GitHub pages. But right here, this shows you the steps to host your project instead of just your personal website. So you need to create a branch called GitHub Pages and push directly to that branch. And essentially, GitHub looks at that GitHub Pages branch and kind of displays what's up there. Why isn't that working? Anyway. Any questions about GitHub Pages, Postman? That's curl.
That's pretty cool though. I like it.